On? Yes, very good. All right, now, shape. You're either going to say definite or variable. Okay, what is solid? Definite shape, definite volume, or vice versa? What is it? What is it? Definite shape and definite shape and definite volume. What about a liquid? Variable shape, very good. And what about its volume? It's definite volume, because you can measure it very easily with a instrument, graduated cylinder. Okay? So it's going to be definite. What about the shape of a gas? Very variable. And what about the volume? Very variable. It's very difficult to, you need special equipment to measure gases. It takes a lot of time and effort. Okay? Now, if you move a substance from one container to another and its volume changes, the substance is a... Didn't we just do this? Look at the board. It says if you move a substance from one container to another and its volume changes, the substance is a... The substance is a what? We just did this. What's the only one that has a variable volume? Gas. So let me read it again. If you move a substance from one container to another and its volume changes, the substance is a gas. Kinetic energy is strongest in a gas. Very good. Let's see what else. How about the particles in a liquid are arranged close but randomly. Which one would be close and orderly? What would that be? Well, let me see. If close and random is a liquid, close and orderly would still be a liquid?
No.
It would be a solid, right, very good. Number 4, if the particles in a material move fast and randomly, the material is most likely a gas. If the particles in a material move slowly or flow, the material is most likely a liquid. Now, what would move fast and flow? Do gases flow? They don't? Of course they flow. You ever see air conditioning? It blows out air. It flows through the vents, doesn't it? But it's much more quickly done, isn't it? Much more quicker. It is quicker. It is faster. The molecules will move very fast in a gas as opposed to a liquid. So if it's said instead, if the particles in a material move quickly and can flow, the material is most likely to be a what? Is anybody with me today? I just said it? No. It's a gas. I said, let's do this again. Can everybody pay attention or no? What do you think? Are you guys all right? Okay. All right, I know, it's Sunday morning. It's very early. Let me read the question as it's written. If the particles in a material move slowly or flow, the material is most like a...
Gas.
Okay. I said that the difference between a liquid and a gas would be the speed of the molecules, correct? So if the material moves slowly and flows and can flow, as it says here, would that be a liquid or a gas? That would be a liquid, right, Luke? Yes or no? Yeah. All right, so let me read the problem as it is, okay? It says, if the particles in a material move slowly or flow, the material is most like a liquid. Are we all right on that? Are we together? Okay. If I reworded the question, may I reword it?
Yeah.
Let me reword it. If the particles in a material move very quickly and can flow, The material is most like a
Gas.
gas. Are you with me now? Are you guys awake? A little bit better? Excellent. Well done. Number 6, the temperature and number of particles in a closed container of gas remain constant. The temperature is remaining constant. If the volume is increased, the pressure will... If the volume is increased, the pressure will... If the temperature of and number of particles in a closed container remain constant and the volume is increased, the gas pressure will decrease. You get that? It will decrease. All right. Number 7. The phase change in which a substance changes from a liquid to a gas. I had it on the board. What's it called? Evaporation. Very good. The phase change in which a substance changes from a liquid to a solid. From a liquid to a solid. Freeze. The phase change in which a substance changes from a gas to a liquid. Condensation. Now here's a short answer one. Use the kinetic theory and or forces of attraction. Explain why a liquid has a definite volume, but a gas does not. Why is that true? It's not chemical, it's not greater bonds, is it? Are you ready? You want to write this down? Liquids have strong attraction between molecules. I'll give you an example. You can put it in parentheses. An example. You ready? Hydrogen bonding. It's an example. Right? We've done hydrogen bonding. We've looked at it. Correct? Put it in parentheses after that. So using the kinetic, says liquids have strong attraction between molecules. Put in parentheses hydrogen bonding. But not so strong that they cannot move. But not so strong they cannot move. The attractions are too strong to allow molecules to separate as they do in gases. Clear? So the attraction, the reason you have a liquid and not a gas is because you do have physical attractions. There are physical attractions between the molecules in a liquid. They're strong enough to keep it as a liquid, but not too strong where they can't go into a gas. Clear? Okay. And that is it. Yes? Are there any questions? Are there any questions whatsoever? Make sure you read everything in the packet. Make sure that you have your questions all done. We'll do maybe a question and answer period. I can do that with everyone. You can ask me questions relative to the book problems. And are there any questions? Luke, you okay? Excellent. Vivian, everything all right? Tony and Harry, how you doing over there, all right? Which one's Tony? Tony and Harry, okay, good. Hard to tell them apart. Tony and Harry. Okay. All right. Have a good one, and we're off.